Okay, so let's begin our discussion with vectors. So now, I'll teach you this topic in such a way that when you come across any question, I think you'll be able to solve. Okay, so I'll be teaching using the questions. So I've got few questions which I would like us to solve together. So the first thing which you have to know under vectors is when you've been given a question, you have first to resolve each vector into its component. So I've got what we call the x component and the y component. And also it is very important for us to know that when we're talking about vectors, we are measuring the angles from positive x-axis. What do I mean? If this is my xy plane, any angle which we are going to be talking about right now, it has to come from this line until to the point of interest. If I have got my vector at that point, so I need to get the angle from this line all the way to that vector. That is very, very important. And then when you are resolving a vector into x component, we use what we call cos. Then in y component, we are using sine. So now let's first solve this question, the first question. So we are saying a displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is as the result of three successive displacements d1 of 100 meters along the negative x-axis, d2 of 200 meters at an angle of 150 above the x-axis, and a displacement d3. Find d3. Let me read the question again. A displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is as a result of three successive displacement d1 of 100 meters at an or along the negative x-axis, d2 of 200 meters at an angle of 150 degrees above the x-axis, and the displacement d3. Find d3. Now you need first to understand, we are saying that if we add d1 plus d2 plus d3, the answer should be the capital D. That's why they are saying that a displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is as a result of three successive displacement. So if we add d1, d2 and d3, we are supposed to get capital D. In this case, this capital D is acting as the resultant. Okay, so capital D in this case is our resultant. Now, like I said, the first thing you need first to come up with a free body diagram. When you've been given a question, come up with a free body diagram. So a free body diagram, you can use xy plane. In this case, I'm going to have my xy plane in this case. So we have been told that we have got a displacement d, which is the capital D, 100 meters from the origin at an angle of 37 degrees above x-axis. Above x-axis is from positive x-axis going in this direction. So we are measuring the angles in anti-clockwise direction. Okay, we are measuring the angles under vectors anti-clockwise direction. Then now, one thing you have to know again is that in this case, this D at an angle of 37 degrees, where can I find 37 degrees? Is it in the first quadrant, second quadrant, or in the third quadrant? 37 degrees is in the first quadrant, meaning I'll just put it here to say this vector is here. Okay, I'll just say that is my vector D. And then I'll say this vector D is 100 meters. So the angle is 37 degrees. I'll put 37 degrees here. I'm done with that vector D. Okay, now is as a result of d1. d1 is 100 meters along the negative x-axis. So when we say along negative x-axis, what is the angle in that case? What is the angle? When you say we have got a vector along negative x-axis, what is the angle? So when we say the vector lies negative x-axis, sometimes negative x-axis, it is the same as they tell you to say, so now this is north, this is south, this is east, and this is west. So if they're talking about negative x-axis, you know that here is negative x-axis in this line. So the angle in this line is 180. Okay. So I'll say that my D1 is 100 meters. The angle is 180 degrees. I continue. D2 of 200 meters at an angle of 150 degrees. Where can I find 150 degrees? 0 to 90 is found in the first quadrant. Okay. Then 90 to 180 is found in the second quadrant. Meaning 150 is in the second quadrant. Meaning that vector here, which is D2, is somewhere here. Which we have it here. So this 150 is from this point here all the way to that line. So that is my 150 degrees. That is my vector D2, which is 200 meters. So this is what we call a free body diagram. A free body diagram is totally different from sketching. If this question was sketch, we can't put it in this form because this is just a free body diagram. A free body diagram is just a diagram, a rough diagram, which you yourself who is writing is able to understand. Okay? But I'm going to teach you again how to sketch vectors. Now, when you come up with a free body diagram, like in this case, we have put this information in XY plane, then you need now to resolve each vector into its component. Okay? So let's first resolve vector D1, or the same D, into its component. This D is going to have dx. So to resolve a vector into x component, you use cos. So in this case, I'll say D, the vector, cos theta. To resolve any vector into x component, we use cos theta. Okay? So now, in this case, I'll say my D is the vector, which is 100. Cos theta, theta is the angle. In this case, the angle which I have is 37 degrees. Okay? So I'm going to say 100 using a calculator, cos 37. What is the answer? I'm getting 79.86. So my dx is 79.86, which is just the same as 79.9. But let's just put 6 like that. Okay? Now it is in meters. That is my x component of vector D. Now I need to resolve the same vector into y component. So it is D. Now I'll use sine theta. To resolve any vector from in y component, we use sine. So I'll say dy will be equal to, my D is 100. Sine the angle is 37 degrees. So what will be my dy? So I'll have 100 sine 37 degrees is giving me 60.18. So 60.18 is my y component. Okay? So let me just put them here. I'll say my dx is 79.86. Then my dy is now what? It's 60.18, like that. And then I need to also to resolve d1 into its components, which is x component and the y component, like that. So I'll say my d1x will be equal to the d1 cos theta. So my d1x will be equal to, what is my d1? My d1 is the vector, which is 100. So I'll put 100 cos the angle now. The angle, since it is going toward west, which is negative x-axis, the angle is 180. So if a vector is going toward north, If a vector is going toward north, the angle is 90 degrees. If a vector is going toward the south, the angle is 270. If a vector is going toward west, the angle is 180. If a vector is going toward east, the angle is 0 degrees. Okay? Now, sometimes they can use north, they can say a vector is going toward what? Positive y direction, or yes, positive y axis. So positive y axis is the same as north. Okay, then negative y axis is the same as south. Negative x axis is the same as west. Positive x axis is the same as east. As simple as that. So you discover to say if they give you information based on these, they will not mention the angle, because they know to say, you know that when they mention north, the angle is 90. When they mention west, the angle is 180. If they mention negative x-axis, the angle is also 180. So you need to know that. That is also very important. Okay? So now, I'm going to resolve D1. Let's go back now. We are resolving D1 into its x and y component. So I'm going to say dx is equal to, I have got 100 cos 180. That is negative 100. Okay, that is the x component of vector d1. Then now I need to resolve again this vector into y components. Into y components, I need to use now cos or sine. I'll say d1 sine theta, like that. So I'm going to say d1 is 100 sine 180. So what is 100 sine 180? That is 0, meaning my d1y is 0. Okay, so now I'm going to push this a bit to create space. Let me put this one here. So I've got d1x to be equal to negative 100, then my d1y to be equal to 0. Now what else? We have also d2. Let's resolve now d2 into its x and y component. So I'll say d2x is equal to d2 cos theta. So what is d2? In this case, we know that d2 is 200. So I'll say is 200 because the angle is 150. Why am I going to use 150? Because this 150, the question was above the x-axis. Above the x-axis meaning from positive x-axis all the way to where the vector is. Okay? So I'm going to say 200 using a calculator cos 150. That is negative 173.21 meters. That is my d2. Then again, I need to resolve this into y component. So I'll have d2y will be equal to d2 sine theta. So d2 is 200 sine 150. So what is 200 sine 150? That is 100. So I have 100 meters. Now I'll put it here again because I don't have space down here. I'll just put it here. I have d2x to be equal to negative 173.21. Then d2y to be equal to 100 meters. Now our goal is to find d3. So d3 we also have, we don't know d3x, we also don't know d3y, the components. So we have to find first the components and then we find the magnitude. Up to this point, any question before we find D3?
I still can't figure out the answers for, like, what are the answers for D1 and D2?
The answers for
D1 and D2.
so D1, after we solved it, I just had to push them here. This is D1x, which is negative 100. Then D1y is 0. That's what we have said. I, I don't know if you have just joined now.
Yeah, yes, I just joined. I'm a little bit behind.
Okay, okay. Okay, I think you understand since I've got the similar question, that is question 2. So just keep on following. I think you'll be able to know what we are trying to come up with. Okay? So now after finding these, the next thing guys is you have to add the x components alone and the y components alone. But the question was the displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is as a result of, so when we add, now what we're going to do is we are saying that dx, now the capital dx, is as a result of d1x plus d2x plus d3x. Then we just plug in the values. D1x is 79.86. This should be equal to, what is my d1x? D1x is negative 100 plus, what is my d2x? My d2x is here, which is negative 173.21. Negative 173.21 plus d3x is the one I'm trying to find. So I have to add these two. So let's add them. So we have 100 plus, that is negative 100 minus 173.21, like that. So I'm getting 79.86 should be equal to negative 183 point, what are you getting? 183. Negative 100 minus 173.21. I'm getting 273. I'm getting negative 273.21, like that. So plus d3x, like that. Now I can shift this to the left hand side so that I remain with d3 only. So I'll have 79.83 or 86 plus 273.21 should be equal to d3x, like that. Then add those two, meaning that our d3x will be equal to 273.21 plus 79.86. So I'm getting 353.07 meters. That is the x component of vector d3. Okay? But I need also to find the y component, then I find the magnitude of d3. So I'll put it here. d3x is equal to 353.07. I'll leave it there. Now I can also get rid of everything here. But before we go to y, if you have got any question, you can ask. Any questions so far? Eh, yes, yes. When answering this question under vectors, you have first to resolve each vector into x and y component. and then you need now to identify which one is the resultant. In this case, we say that D is the resultant because the question is saying D from here. Let me just show you the question again. How can you know that D, in this case, the capital D, is the resultant? Because they have said a displacement D of 100 meters from the origin at an angle of 37 degrees above the x-axis is the result of the three successive displacement. Meaning, when you add D1, D2, and D3, you get the result which is capital D. So in that case, that's why we have discovered that D is the resultant. So you have first to resolve each vector into x and the y component. After that, then add the x component alone, equate it equal to the resultant of that x component. Do the same with y. Is that okay? Now let's now find the y. So the y is going to be dy is as a result of d1 y plus d1 d1 or d2y then plus d3y. What is capital dy? It is 60.18. See here, 60.18 should be equal to, what is d1y is 0, d2y is here 100 plus d3y. So shift 100 to the other side, you have 60.18 minus 100 should be equal to d3y. So what is 100? What is 60.18 minus 100? That is negative 39.82 should be equal to d3. So that is my d3y. Okay, so my d3y is now negative 39.82, like that. Now after finding the component of dy3, you have now to use Pythagoras theorem to find the magnitude. How do you find the magnitude? When finding the magnitude, you say d3 is either you use an r on top or you can put it in modulus. If you don't use this as a vector, then you are talking about scalar. If you just say the resultant vector of d3 is equal to the square root of d3 x squared plus d3y squared, just like this, then they'll consider this as a scalar and not a vector. So you have to put an r on top, or you have to put it in modulus like the way I put it here. So you choose. So in this case, I'm going to be using the arrow. So I'll say my vector d3, okay, will be equal to the square root of d3x squared plus d3y squared. So this is how you find the magnitude. So now this will be equal to, if I put the values inside here, I have got my d3x to be 353.07 squared plus negative 39.82 squared, like that. So if I square here, meaning it's the same as the negative will not have any effect. So what will be the answer? 353.07, I square it, plus, just put plus because that negative will not affect anything. If I square the negative, I'll get positive. So I have 39.82, I square it. The answer I find, then I get the square root. I'm getting 355. So 355.3 meters. That is my magnitude of D3. You can even clearly see that on top here, the answer is 355. Okay? Any question on how to find the magnitude? Okay. Now, A vector can't stand alone without the direction. When you find the vector the way it is, here the question is find d3. When you find d3, you have first to find also the what? The magnitude or the direction. When we're talking about the direction, we're talking about the angle. So how do you find the direction? I'm going to teach you a simple way on how to get the direction. So if you resolve the x and y component, you discover that your x component, like in this case, my x component is positive, you can clearly see here, and the y component is negative. If this is my xy plane, I can clearly see that, let me just put it from here. This is my positive x, this is my positive y, this is my negative x, this is my negative y. Get me clear there? If you discover that your x component, I can even get rid of this. I put this d3 here. So I'll shift this to this part here. I'll say that's my d3. If you discover that your x component is negative, your y component is also negative. Or let me start with positive, positive. After resolving the x and y component, like in this case we have resolved it, and then the answers are negative, this is negative, this is positive. But in a case where you come across both are positive, just know that the angle is in the first quadrant. In the first quadrant, that's where we can see that y is positive, x is positive. So when the angle falls in the first quadrant, you use this formula. Theta is equal to tan inverse of the y component divided by the x component. The answer you are going to find here, that is the direction we are talking about. Meaning that is your answer. If the x is positive, the y is positive. Okay? What if we change? If the x is negative, the y is positive. Definitely we can clearly see that that angle will be in the second quadrant. So if the angle falls in the second quadrant, what you do is, after using this formula, the answer which you are going to find, you have to say 180 minus the theta which you are going to find using this formula. Meaning that is the angle we are looking for. Okay? And then if you discover that the x component is negative, the y component is also negative, the angle falls in the third quadrant, sorry. In the third quadrant, you say 180 plus the theta which you are going to find using that formula. If the angle falls in the fourth quadrant, you discover that the x component will be positive, the y will be negative, meaning the angle falls in the fourth quadrant. In the fourth quadrant, you say 360 minus the theta you're going to find using that formula. And you're going to see how we are going to be solving this as we are solving these questions today. Now, the first question I can ask you here is our x component d3x is positive and d3y is negative. Where do you expect this angle to be? Is it in the first quadrant, second quadrant, or in the fourth quadrant? Sorry? Where do we expect our angle to be?
In the fourth quadrant. Third quadrant.
Okay, so now I'm from telling you that this is positive x.
Sir,
Yes.
seeing that our y is negative and our x is positive, it will fall in the fourth quadrant.
Fourth quadrant. So our friend here is saying since our y is negative, our x is positive, it's going to fall in the fourth quadrant. How many are in support with that? Then how many are saying it's going to fall in the first quadrant? Anyone who is saying okay, second quadrant? Okay, since the x is positive, the y is negative, definitely the angle has to be in the fourth quadrant. Now, in the fourth quadrant, one thing you have to know is When you use this formula, when using this formula, when you're using the technique which I'm trying to give you right now, one thing I have to tell you is that the formula is d3y divided by d3x. But you ignore the negative when you are plugging in the values. So like in this case, I'll say d3y is 353.07. I divide, instead of me saying negative 39, I'll just say 39.82. No one is going to penalize you. Just ignore the negative. Okay? So you say, you click on shift, you can mute your mic. So now what you're going to say is you click on shift, then you click on done, open brackets, 353.07 divided by 39.82. Then you close the brackets. So the answer I'm getting right now is um, 83. Okay, let me do it. We are saying shift done, open brackets. We have the y component. Oh, I've swapped them, right? The y is 39.82, and the x is the one which is 353.07. Yes, like that. So my theta will be equal to, I'll say shift tan, open brackets, 39.82 divided by 353.07. Then I close the brackets. Okay, so I'm getting my angle to be 6.443 degrees. But since it is in the fourth quadrant, I said if the angle falls in the fourth quadrant, remember we're getting the angle from positive x-axis, so I have to say 360 minus the theta, which is 6.43 degrees. So the theta, the actual theta I'm looking for right now is for 360 minus 6.43, which is 353.57 degrees. So this is the angle which we are looking for, which is here. So you need to know, before you even solve the angle, you need to know to say this angle falls in the first quadrant, second quadrant, third quadrant, or in the fourth quadrant. That is very important. If the angle falls in the first quadrant, when you use this formula, the answer which you find, that is the answer you are looking for. Okay? If you discover to say the angle falls in the second quadrant, the answer you find here, you say 180 minus the answer you have found here, if that angle falls in the second quadrant. If it falls in the third quadrant, you say 180 plus the theta, provided that when you are plugging in the values here, ignore the negative. Don't put negative here. So that is the basic idea behind vectors. So this question explains almost everything about vectors. Unless you have got question before we go to the next question.
I'm the one who joined late, so I'm waiting.
For the next question.
Told me how you cover what I missed in the next question.
Yes. So for those who joined at first, any questions so far? Okay, so let's go now to the next question. So yes,
Hello?
yes, Peter.
I was saying I have under, I was saying I have understood, sir.
Okay, thank you. Now let's crack this question. This question is very interesting. I think I saw someone asking about this question in e-study group about a plus b, a minus b, and b minus a, something like this. So the question is find the direction and magnitude of, we have been given everything here. So we have been given a free body diagram already on xy plane. But remember, when getting these vectors, okay, when getting this direction. I mean, you have to get it from positive x-axis. For example, I have first to resolve each vector into x and y component. Okay, so let's first resolve each vector into x and y component. To resolve a vector ax, which is going to be a cos theta, like I said, if we're resolving any vector into x component, we use cos. So ax is equal to a cos theta. Okay, then I'll say a x will be equal to, my a is a vector 30 cos the angle. Now, which angle am I going to use? Remember, I said we are getting the angle from positive x-axis until where the vector is. So that is my vector. So how can I find, initially this is 25 degrees and not 250? The one who was typing this, there was just an error. It's supposed to be 25 degrees and not 250. So how can I find this angle, guys, from this point here all the way to that point? I know that if I have got something like this, from this point all the way to that point is 180. So since I've got the angle there, which is 25, I need just to say 180 minus 25. So what is 180 minus 25? 155. Meaning the angle which I'm going to use is 155. So I'll use 155 degrees. I'm getting the angle from positive x-axis. So I'll say my ax will be equal to, yellow is not visible, so I'll say 30 cos 155. You have got a question, Justina? Okay, so now I'm getting negative 20. Yes, please.
Like, what would be the angle going in the direction east to north?
Or east north. Okay,
Like we are going to east north.
you're asking about east north. Okay, I'm going to explain that. When we're talking about east of south, east north, I'm going to explain that. Is that okay? Okay, thank you. So my x component in this case is negative 27.19. Let's find the ay. So ay will be a sine theta. When you're resolving a vector into y component, we are using sine. So my vector is 30, sine the angle is the same, 155. So ay will be equal to 30 sine 155. That is 12. 12.68. That is my y component. Let me just put them here to create space. So I'll say my x is negative 27.19. Then my ay is 12.68, like that. Then now I get rid of this. I need to resolve vector b now. Now, which angle are we going to use for vector b? Remember, we are getting the angle from positive x-axis, from this line all the way to that point. Now that I've been given this angle is 20 degrees and not 200. That was just an error. Now that I've been given a 20 degrees that side, I'll say 360 minus 20 degrees, which is what? 340, right? 340 degrees. So now I'm going to use a 340 to resolve my vector b into x and y component. So I'll say bx is equal to b cos theta. So my bx is now, b is 20, then cos 340. So my bx will be equal to 20 cos 340, which is 18.79 meters. Let's also resolve b into y. y component. So it's b sine theta. So by will be equal to my b is 20. Then I've got 340 as my angle. My by is 20. I'm using a calculator. Sine 340. That is negative 6.84 meters. Even this one in meters. So I'll also put these two guys, my bx to be 18.79. Then my by to be what? My by to be negative 6.84 meters. Then now the first question, you need first to resolve each vector into x and y component. Then the first question is find the sum, find the direction and the magnitude of the sum a plus b. So what is a plus b? Now this a plus b, one thing we have to know here is that when I'm adding these vectors, okay, I need to get the x component and the y component. So I'm going to say my a plus b, you put them in the brackets, then you put x here, meaning this is my x component of a plus b. Does that make sense? A plus b, put them in the brackets, put x, meaning that is the x component of a plus b. So meaning this is as a result of ax plus bx. We are dealing with plus. That's why I'm putting plus here. So what is ax? Ax is negative 27.19. What is bx? Bx is 18.79. So what is our answer in this case? Our answer will be negative 27.19 plus 18.79. The answer I'm getting is negative 8.4 meters. That is my x component of a plus b. Does that make sense? Before I go to b, does that make sense? So for y component, I'll also do the same. I'll say, yes please. Any question?
So it's like they've given us the the 10.22 and 145.16, and then we have to
Yes.
work out.
Yeah, exactly. These are the answers which have already been given. So when we are solving, we need to come up with these answers.
Oh, okay, go on. I would
Okay.
like to see how. Yeah, now I would like to follow.
Okay. So now I need also to find the same thing, but I just need to put y. So I'll say a plus b in the brackets, I put y. This is a result of a y plus by. So what is my ay? My ay is 12.68. What is my by? My by is negative. Now since I don't have enough space, let me just shift this part a bit here. What is my by? My by is negative 6.84, like that. So what is my answer? So 12 plus 0.68, that is negative. Now I'll say minus 6.84, like that. So the answer I'm getting, guys, is 5.84, like that. Now to get a plus b, you say a plus b, you put them what arrows on top there, is going to be equal to the square root of this component and that component. So you say in the brackets a plus bx, or you can say a, in fact if you want you can just say ax plus bx, then you put them in the brackets squared plus again ay in the brackets plus by in the brackets you put squared like that. Then put now those values. Let's see what we're going to have. I think let me just do it from here on top. I'll have the square root of my first part is negative 8.4. Now I square it, plus the second part is 5.84. Now we square it. What are we going to have? So that negative is same even if you ignore it because you are squaring it. So it's 8.4, you square it, plus 5.84, you square it. So the answer you are getting, I'm getting 104.6656. You get the square root. So the answer I'm getting is 10.2, 10.23. So 10.23 meters is my answer. Now in this case, since they were just rounding it off before they arrived on the final answer, that's why it was 10.22, like that. So that is the magnitude of a plus b. Now a vector can't stand alone without the what? The magnitude. Sorry, the direction, like I said. Now here the x component is negative, the y component is positive. Where do we expect our angle to be? Let's see. The x component is negative, the y component is positive. Where do we expect our angle to be? Yes, please. Where do we expect our angle to be?
Second quadrant.
Second quadrant. The angle has to be in the second quadrant because the x is negative, the y is positive. So in the second quadrant, I said after using this formula, so in this case the y component, I will say the y component is 5.84. The x component, I say just ignore the negative. Okay, so I'll say shift then tan, open brackets, 5.84 divided by 8.4, like that. You close the brackets. So the answer I'm getting is 34.81 degrees. Now I said if the angle falls in the second quadrant, you have to say 180 minus the angle, which is minus 34.81. The answer I'm going to get now after doing minus, that will be my final answer. So what is 180 minus 34.181? I'm getting 145.19. So in this case, that is my angle. Remember, we are always measuring the angles from positive x-axis. That's why we are doing all this when it comes for vectors. So the magnitude of a plus c, the sum of a plus b, is 10.23 meters at an angle of 145.19 from positive x-axis. Now, sometimes you might be wondering why is it that this is 145.16, just because we were rounding it off before we reach at the final answer. But this is the same as 145.2. Even this one is the same as 145.2. As simple as that. Does that make sense? Now, the crucial part here is, before I move to part 2, any question? So part 2 is very much interesting. So I think the best thing what we can do is, I want us to solve part 2. Then part 3 I'm going to give you as assignment. You solve this right now and send the answers in the group so that we see if you have understood. So I'm going to solve a minus b. Okay? So what is a minus b? You do the same. It is minus. You say a minus b. You put them in the brackets, the x component. So since we are dealing with minus, you say ax minus bx. Okay? So what is our ax? Our ax is negative 27.19. Minus, what is our bx? 18.79. What will be our answer? So our answer will be negative 27.19 minus 18.79. So the answer is negative 45.98. I'll do the same for y in y component. So it will be a minus b, now the y component. It will be ay minus by. So if we're dealing with minus, see here I've put minus. If you're dealing with plus, you put plus. So I'll say my ay is 12.68 minus, again there's also negative there. I also don't have space again here. I'll just shift there. So I'll have my y is 6.84, like that. Let's find the answer. So negative negative will get plus, so we'll have 12 plus 0.68 plus 6.84, like that. I'm getting 19.52 meters. As simple as that. After finding this, then you say now our a minus b, put the arrows on top to show that we are dealing with vectors, is equal to the square root of a minus b, you put them x, y, then in the brackets squared, plus ay plus, or minus, let me just show minus there, minus by in the brackets, then you square it. Again, I'll continue it from here. So it will be the square root of, the first part is negative 45.98 squared, then plus the second part is 19.52, again I square it. So what will be our answer? So I'll have 45 negative, just ignore it because you are squaring it. You get a positive. Okay, so I have 45.98 squared plus 19.52. I squared. I get the square root. So I'm getting 45.9. Okay. 45 or 49, sorry. I'm getting 49.95 meters. That is my answer. Okay. Then now, if I want to find the direction, considering to say the x component is positive or negative, sorry. Yes. Yes, Johnny.
Finally, on when finding the magnitude,
Yes.
where you have written x ax minus by, there is an error. You can well, you have written y instead of writing x.
Oh, okay, okay. I've seen it. Thank you.
Where you have square root, yeah.
I've seen it. Thank you. It's supposed to be x, right? Here is supposed to be x. Thank you. And then now the x is positive, the y is negative. Where do we expect our angle to be? Let's see. Where do we expect our angle to be? Yes,
Fourth quadrant.
in the fourth quadrant. So what did I say about the fourth quadrant?
The fourth quadrant, x is positive, y is negative.
So now after finding the angle using this formula, then what will be the next thing? The y is 19.52, the x is 45.98. So after finding this theta, just a minute, I'll say shift tan open brackets 19.52 divided by 45.98, then I close the brackets. I'm getting 27 or 23, sorry, I'm getting 23 degrees. Okay, just like that, 23 degrees 0.00. So I'll leave it there. After finding this angle, what are we supposed to do now to find the actual angle we are looking for? What did I say?
We have to subtract, since we are starting from the positive, from the x, the positive x.
Mm-hmm.
So we can say 360 minus 23 to find the actual.
Exactly. So you say 360 minus 23 degrees to find the actual angle because it falls in the third quadrant. So you say 360 minus 23, which is 337. Not so. So now here what they did was they swapped the answers. This answer was supposed to be there and this one was supposed to be there. Now I want you to go ahead and find b minus a. What do we mean when we say b minus a? B minus a, you just switch these. You say bx, you do this. Let me show you here. Where is it? When you're finding b minus a, you say b minus a like that. Then x, you say bx minus ax. For y, you do the same. Then find the magnitude and also the direction. So you have to find the magnitude to be 49, the same, but the direction will change. The direction will be 157. Go ahead and find, then send the answer in the group if you are in the group. If you're not in the group, you can send the answer in the comment section. So this is what I had for you. And then we also have more questions, like for example this question where I wanted to explain about north of east, but I think the best way, what I'm going to do, I solved all the questions here. I'm going to send you the link in the group so that you watch, and then you need to understand what it means when you say north of east. Okay, so let me show you other questions, other more questions which I solved. So all these questions, as you can see here, all these questions, I have the video, the full video. I think I'm going to share in the group. Then sometimes if you would like to access more videos from our website, we have got the website. If you go on Google, you search Transcended Institute, you'll be able to see this website. So when you go on our website, I want to show you on how you can access the private videos. I believe when you go on YouTube, there are some videos which are showing you to say you can't access them because you are not a member. I think you have come across such, not so? Have you come across any video which is okay? So now there are these videos. This is our website. This is our website. So if you click on physics, I want to show you physics. If you click on physics, you'll find these topics. You'll find dimension analysis, vectors. We are from doing vectors. So if you go on vectors, you'll find that there is introduction to vectors, how to find direction in vectors, how to sketch vectors, terms used in vectors. That's where there is north of east, east of west, northwest, then free body diagram versus sketching, then practice questions. So these videos, they can help you to understand the full topic of vectors. Then there's also linear motion. Linear motion is the same as kinematics. We also have these questions. There is the kinematics detailed with questions, velocity time graph, kinematics detailed with questions, then velocity time graph, also free fall motion detailed. Now these videos, you can't find them on our YouTube channel. You can only find them on our website. Okay, so we have almost all the topics for both semester 1 and semester 2. So what you can do, you can just check out our website. Then if you want to access these videos, you can just register with Transcended Institute. Then you'll be able to access this. So every time you have got class, you use this Google Meet. You click there, then you join the class. So this is what I had for you today, unless you have got questions.